often think that the Milky Way is seen as a flat spinning disk of gas, dust, and stars. But if you zoom out and make an edge-on photo, there's actually a distinctive warp. Why is that? Hello everyone, my name is 𝐬𝒂𝒏𝒈 and welcome to Takdang Aghamin Episode 2, where we tackled the question, what caused the Milky Way's warp disk? Astronomers have pondered the same question for years. There have been various theories such as the influence of the intergalactic magnetic field, effects of a dark matter halo, or maybe even a large amount of unseen matter that is expected to surround galaxies. Data from the ESA, or the European Space Agency's star mapping satellite Gaia, shows that the Milky Way extends outward more than expected, and the edges seem to have a rippled structure. A further analysis that shows a warp to the outer edge of the galactic disk. This suggests that it was caused by ancient galactic collisions such as the Sagittarius dwarf galaxy about 6 billion years ago. A study conducted by the ESA shows that the warp moves around the center of the Milky Way faster than expected, completing one rotation in 600 to 700 million years. But it is slower than the speed at which the stars in the disk, our mother star, the Sun, orbits the galactic center. The distortion might have been caused by an ongoing collision with a smaller galaxy that sends ripples through the galactic disk, like how you throw a rock into the water. We know that our galaxy, the Milky Way, is surrounded by a diffuse cloud of stars called the stellar halo, which extends far beyond the galaxy's main disk. A major study led by researchers at Harvard found that the Milky Way's stellar halo is elliptical, flattened, and tilted, giving it a shape somewhat similar to a football. The team assumed that the same shape for a dark matter halo, a larger entity that extends across everything in and around the Milky Way. That's why 80% of dark matter makes up the galaxy's mass. However, it is invisible because there is no interaction with light. The shape of the halo might be inferred, and if the halo has an irregular shape, the gravitational force could even bend the galactic disk. Most mass in the galaxy is contained within this dark matter halo, influencing the structures of the galaxies over time. The central question is whether the phenomenon is widespread enough to produce the structure we observe in the Milky Way. Authors like J.J. Han begin looking at the data from the TNG-50 from the illustrious TNG simulations. These are supercomputer simulations of galactic evolution, which include dark matter and cosmological evolution, as well as the detailed magneto-hydrodynamic interactions or electrical charge gas, and magnetic fields interacting with different galaxies. This data shows that the inner region of the dark matter can be significantly tilted to the galactic plane and can be caused by both galactic collisions and pass very close to one another. The tilted halos can remain for billions of years, giving them enough time to cause the galaxy's disk to warp. Now the next question is the Milky Way's warp disk dangerous? And if it is, does it affect our planet and the way we live? The answer to the question is no, it doesn't, because scientists and astronomers have researched that there aren't any noticeable effects to the way we live. According to the ESA, the Sun in our solar system is located in a relatively flat part and is close to the center of the Milky Way, which is about 26 light years away, from where the amplitude of the warp is very small. From our point of view on Earth, we do not see the bending of our galaxy. Moreover, researchers have reached farther out regions about 52 light years from the center and beyond, where you can see the warp disk is more noticeable to the outer parts of the galaxy. For more exciting and galactic stories, don't forget to like, subscribe, and follow our socials. That is all for now. Until next time, stay curious because the universe always has something to reveal.